Today I will talk about our longitudinal study in privacy leaks across Android versions. So to start, the motivation of our work is that we use so many useful apps in our phones. We are constantly reminded to update them once in a while. And we were told that this is for the benefit of bug fixes and performance improvement. However, I often wonder, is there any privacy change if I update the app? So the reason I'm asking the question is that during our research group is helped the production of a documentary film that follows a regular woman's life for 1 week, and we monitor her mobile devices to detect privacy leaks from the apps she was using. What we find is that during this week filming, there's 3,545 leaks of location. What this means is that there's one location leak every 2 to 3 minutes. And we find that some of the leaks are actually in the background. That's confirmed by the woman. So most of the leaks come from an app called Joanne, which is a craft store app store. And we investigate the other versions of this app. What we find is that we observe really different patterns. What we did is we interacted with the different versions for 5 minutes. And during these 5 minutes, we monitor the number of times that the location is leaked. So in the beginning of 2016, there's no location leak. Then it becomes really aggressive. And in 2017, the intensity reduces. So this is just one app. What we really want to understand is the big picture. How do mobile privacy evolves over time? Is it getting better or worse? So before answering that, I'd like to define the privacy in our work. We specifically focus on 3 aspects. First question is what information is shared from our phone. We focus on personally identifiable information. And then when they are shared, how is it being shared, whether it's through encrypted channel or it's in plain text. Another dimension we look at is who gets this information. Is it the first party, the app owner, or the third party like advertising and analytics providers? So why do we care? We defined the 2 threat model in our case. The first scenario is for the purpose of data aggregation. The information is shared to first and third party. And then during this transmission, if they were sent in plain text, it's susceptible to eavesdropping attack. In both scenarios, we consider as the information sharing as privacy leak. So by leak, what I mean is not water leak or leak of classified information, but like water leak, what we are trying to understand is when information is leaked from the device to the outside world. Specifically, we are referring any information that is sent to first or third parties through encrypted or plain text channel. And this covers a wide range of information. However, we acknowledge that there's some information sharing are necessary for the functionality. So we explicitly excluded the case when credentials are sent to first parties through encrypted channel. So this definition may be a little expensive, but what I'm doing here is really to increase the transparency of information sharing by different mobile devices. So users can make a judge of their own whether the behavior is suspicious. By this definition, a leak may or may not be a violation or intentional. Now I've cleared the definition for privacy. I'll talk about our methodology. First, we want to conduct a controlled experiment for a large amount of apps. Well, the first step is really to select apps. We want to include popular apps that are used by most of the population, and we also need to access to historical versions. In this end, we explore the undocumented Google API to download the historical versions. Also, because of the system we are using to detect privacy leak, we want to make sure that we are able to man in the middle of the traffic. So after the filtering, this got us 512 Android apps that covered over 7,000 unique versions. the timeline is spent over 8 years. And here in Android system, we use APK to refer a unique version. An app may have multiple versions. Now we have collected a set of apps we are looking at. The next question is how do we measure them? So for each version, we interacted with that app, and we detected the leaks from the app using a previous system called Recon, and we manually validated the result. So as for interaction, it is ideal if that we are able to do it to do real controlled user interaction. However, we are talking about 7,000 apps, which is not very scalable. So what we did instead is to combine automated and scripted interaction. For automation, we use Monkey to generate random user events to interact with each version. However, this does not cover the case when you need to log into the app to use most functionalities. So to remedy that, we manually log into the app and record the user interactions, repeat it across all versions. Each experiment lasted for about 10 minutes on average, and they were conducted in 5 real Android phones. Specifically, we use man-in-the-middle proxy to intercept both encrypted and plain text traffic. Now, after the interaction, I was able to induce the leaks to the internet. Well, how do we detect those leaks? We collect the network traffic and use a system called Recon that uses machine learning algorithm to detect those leaks without knowing them ahead of time. And of course, there's false positives and false negatives. So we manually validate the result because we have it's controlled experiment and we have ground truth information. So this gives us a basic profile of each app, their privacy leaks. Now I will talk about the information we collected. First, we have different versions of apps, and each version is corresponding to their release time. That's ordered chronologically. And we looked at the set of PII that's leaked by each version, and how it is being leaked, whether it's in HTTPS or HTTP traffic. Another dimension I just talked about is where it goes, whether it goes to a first party, like in the Pinterest app, the Pinterest domain, or a third party the tracking domain. So this gets us 3-dimension metadata of each app. Now I'll show you a case study. Here, I'll show just to show first one PII type leak. Over time, if you look at the last bar, the advertising ID is leaked 12 times to both first and third party. And we have this information for different PII type. Now, the first thing that's standing out is the password leak. 2 versions of the apps we've studied, they send it to a third-party library. And this is Pinterest. It's used by millions of users. So we did a responsible disclosure, and the developers fixed it within a month. Another significant finding is that if you look at the last few columns, there's more PII types that were leaked in more recent versions, including gender, location, and so on. So not just the unique types, but also the frequency of leaking a specific type changed over time. If you look at the Android ID, it was leaked only 2 times in 2013. However, it's increased to over 200 times in 2016. Another dimension we look at is the protocols they were used. In the case of location, in half of the time, they were actually leaked in plain text. So this is just one app. We see a high variance in privacy across versions. And I'd love to show you all the 500 apps we've looked at, but there's not enough time. So we have this web tool that published all the data and for you to explore on your own. Specifically, we also disclosed about the domains that are contacted by each app. So that's just one app. Now, if you look at the time, it's hard to look at the big picture. Right now, I'll focus on the aggregate result. First is the summary of our findings. This is a bar graph that shows the x-axis is the different PII types, The y-axis is the percentage of APKs or apps across all the apps we've tested. The first thing you'll notice if you look at the left side, tracking identifiers, different tracking identifiers and locations, they dominate the leak, just as previous studies have shown. Now, if you compare the red and the blue bars, you will notice that the percentage of apps is always larger than the APKs. What this meant is not all versions leak PII type. Another common thing we've always find is the password leak. In this data set, we find that some versions of 6 apps, they leaked the password in plain text, and some versions of 7 apps, they actually shared it to undisclosed third parties. So far, there are 4 of them still ignored our responsible disclosure, which means the problem still exists today. So this is the summary of the result. Now I will talk about different dimensions. So first is the PII leaks. Especially, I'm interested in understanding the frequency of change. If you remember the Pinterest case, the Android ID increased from 2 times to a couple thousand, 100 times. And this is actually not rare in our data set. This is a CDF of apps in terms of their differences in leaking frequency during our 10-minute interaction. So for most of them, the differences are less than 10 times. However, their significant fraction exhibit several order of magnitude differences. What this means is that during 10 minutes interaction, some versions leak location or advertising ID for hundreds of times. It's really upsetting because its profile in a really fine-grained detail, and it drains the battery if you keep the GPS radio active. Also, this increased the opportunity for eavesdroppers to invade the user privacy. So that's the PII. The next aspect is the protocols used to transmit the information. In the website, it's easy for once the domain supports HTTPS, every browser can easily transfer to use that protocol to secure the data. However, in the mobile app side, usually you might need to update the apps if they are hard-coded the HTTP protocol in their code. So what we find is that in order to use the HTTPS in apps, it's really slow. For half of the domains we've looked at, if you want to 10% of the apps to support HTTP, it takes 2 years. And it will take another 3 years for half the apps to support the protocol. Another dimension is the destination parties who got this information, especially third party. They are less known to average users. And I'm specifically focusing on the tracking IDs. So tracking identifiers is unique for each device and usually do not change over time. The tracking ecosystem usually send this using this to track users along with other users' activity, like where they are and their basic profile information. What they can do is potentially build a profile linkage between these 2 pieces of information. So we go out and aggregate this information across different apps. And the table here, the first column is the destination domains that receive the PII. And the second column is the linkage you can build with tracking identifiers. Not surprisingly, Google-owned domains, they collect a rich profile of a user. However, less known domains they are also find to exhibit similar behaviors. And we find that there are actually over 100 domains doing this type of things. And what this means is that they can potentially link information to a track ID permanently. So that's different aspects. How about we combine them? And what we really want to know is privacy getting better or worse? In this case, we go out and combine the different dimensions. And what we find is that over time, the combined risk from PII destination, PII types and domains that are receiving are actually the dominant change. So the combined risk was over time, and this is mainly due to we find that more PII types were leaked and more domains were contacted. So to conclude, by the definition of our privacy, it has been worsened over time. In different, this evidence can be found in different dimensions. And there's a clear need for continuous monitoring of those mobile apps we are using existing systems like Recon, Lumen, and Monitor. Also, I would like to point out that we still recommend you to update the apps for security reasons. And another thing is that those leaks are not necessarily caused by the developers. They may not know what third party does. So to this end, we'd like to build a tool that increases the transparency of PII that can benefit the different parties to understand the local ecosystem. With that, thanks for listening, and I'm happy to take questions.
Hi. So I'm wondering, do you have information on the categories of the apps?
Yes.
Because you could probably slice and dice this accordingly. And it might be interesting to see the ones that are using location a lot are probably maps-based or, traveling directions. And so those kinds of apps, it makes sense for them to use your location.
Yeah.
Right,
so in our paper, we specifically look at how it's different across different app categories. And if I remember correctly, some of dating apps, they tend to use locations more and collect more type of information. Yeah.
Okay, and my second question is the thing that's hard about when you see apps asking for more privacy, more data over time, like let's use location as an example, you really have to check if the app is changing its functionality, right? So sometimes new requests for data or permissions or so on is happening because they're changing the app and they're adding some functionality. So I'm wondering if you had a chance to look at some of the apps where you saw growth in, from one version to the next is what I'm talking about. You have to check the functionality of the app too to see whether we call it a privacy issue or not.
Yeah, especially this is a long time frame, so definitely there's some apps might change their functionality, like add new features. So our point is more like to understand when you add these new features, do you actually collect more information? And this is the work that we've tried to give users the transparency.
Okay, thank you.
Thank you.
So I would like to ask a kind of a follow-up question that follows up Nina's earlier question for the first speaker. So among all these, I would call it voluntary or involuntary disclosure instead of leak. How many of these cases are, are actually from a scenario where based on user agreement, information of those categories was kind of legally disclosed?
So like reading the terms of use is really
right, like among all the apps that you have surveyed.
Yeah, we didn't look at what exactly they claim to collect for what purpose, but however, for the case of password, that's very clear. Then we only disclosed those parts.
Of course.
Yeah.
Okay.
But if they definitely, I think there's other study looking at conducting surveys on their terms of use, try to figure out how what they collect is compliance with what they claim to collect. Yeah.
Okay.
But definitely interesting point. Yeah.
Thank you.
Thank you.
Other questions? If not, let's thank Jingjing one more time.